2. Systems Development Lifecycle. It's a challenge to develop and deliver software. Developers need to quickly build secure solutions that are reliable and can scale to meet customer demands. Operational stability and rapid feature development are two goals that might seem like they're far apart, and methodologies are needed to bridge the gap between them. The Systems Development Lifecycle, also known as the SDLC, helps to bridge the gap between the stability of an organization's operations and the need for rapid feature development. The SDLC is a model that's used to describe the stages in software development. These stages include the initial feasibility study all the way through the deployment and ongoing maintenance of an application. In general, the steps in an SDLC methodology are plan, define, design, develop, deploy, and maintain. This course will primarily focus on the develop phase, but will also touch briefly on the deploy phase. During the develop phase, developers and engineers acquire and install new system components and applications. System users are trained, and all aspects of the new system are tested for performance. If needed, bugs are fixed and adjustments are made to improve performance. Common SDLC methodologies are waterfall and agile. The waterfall, or traditional methodology, uses sequential development phases, which have distinct tasks and goals. Work is passed to the next phase only after all tasks are completed in the current phase. Waterfall projects often have long periods of time between when the software is first planned and when it's deployed. This also means the customer doesn't have an opportunity to provide input until after the software is completed. The Agile methodology is a framework that uses an iterative development process. Each iteration is referred to as a sprint, and each sprint includes the different phases, from planning through maintenance of a software product. Sprints average 1 to 4 weeks long. Each iteration builds on the last until the completed product is deployed. Because sprints usually have short durations, customers can provide input and direction as the product develops. This also means that requirements can change, and these changes can be incorporated into the application's development. The major phases of software development are develop, deploy, and maintain. The develop phase can be further divided into the code, build, and test phases. During the code phase, developers write the application source code and use a source code repository, such as a Git repository or an AWS code commit repository, for version control. Teams might use code reviews or pair programming to provide feedback on code quality. In the build phase, developers compile the source code and verify the quality of the code by using different tests. One type of test is a unit test. A unit test is written in code and helps to ensure that the application logic meets requirements. Tools used here include style checkers and code metrics utilities. Other tests include integration tests, load tests, user interface tests, and penetration tests. Integration testing checks how well the code works for other systems. For example, the connection to the database server is tested. During load testing, utilities simulate user traffic on the application. Load tests are critical because they help ensure an application will perform as expected if it has a large number of users. In user interface tests, or UI tests, users test how the application works. The selected testers open the application for the first time and use it. UI tests help developers know whether the application is easy to use and functions as expected. Finally, during penetration testing, the security team checks whether the application infrastructure is resilient to attacks from outside the organization. The purpose is to simulate situations where malicious, unauthorized users attempt to take over the application resources. The next main phase is deploy. During this phase, the application is deployed to production. Different deployment strategies exist, but the common goals are to reduce risk when new changes are deployed and minimize the impact if a bad change is released into production. Finally, the application enters the maintain phase. During this phase, end users use the application regularly. Operations teams ensure the application runs as expected, and security teams monitor the system for any signs of a problem. Thanks for watching, and see you in the next video.
AWS. For accessibility, Step 1. Create an AWS account. Step 2. Set up AWS permissions with IAM. Step 3. Install the development environment with AWS IDE toolkits. Step 4. Interact with AWS services with AWS SDKs and AWS CLI. And description. Before you start developing applications on AWS, you must do a few key things. First, you will need an AWS account, and you must also create an AWS Identity and Access Management (IAM) user. This process includes setting up AWS permissions to access specific services and operations. Next, you must install your development environment for your language of choice. You must then install the AWS SDK for the language that you will use, or the AWS Command Line Interface, or AWS CLI, so that you can interact with AWS services. This section will discuss each AWS offering that's involved in setting up AWS permissions, installing the development environment, and interacting with AWS services. Permissions will be covered in another module in this course. The steps to create an AWS account are as follows. Open the AWS homepage at http://aws.amazon.com. Choose Create an AWS account. Note, if you signed into AWS recently with the same browser, choose Sign into the console. If Create a new AWS account isn't available, then choose Sign into a different account and then choose Create a new AWS account. Enter the requested information and then choose Continue. Select if the account is personal or professional. For learning purposes, select Personal. Note, both types of accounts, personal or professional, have the same features. Enter either your personal information or company information to continue. If you are creating a professional account, enter the company's phone number and an organizational email address. Configuring a professional account with a personal phone number and email address can make an account less secure. Ensure that you can access the email address that you used. You will need to access this email address to receive the confirmation message that your account was created. Read and accept the AWS Customer Agreement at https://aws.amazon.com agreement. Finally, choose Create Account and Continue. When first you create an AWS account, you begin with a single sign-on identity that has complete access to all AWS services and resources in the account. This identity is called the AWS Account Root User, and it's accessed by logging in with the email address and password that you used to create the account. A best practice is to not use the root account unless it's required. Instead, to increase the security of your AWS account, we recommend that you create an IAM user that will use access credentials instead of using your AWS account credentials. IAM is a service that helps you securely control access to AWS resources for your users. You use IAM to control who can use your AWS resources, authentication, and what resources they can use and in what ways, authorization. IAM enables you to create and manage users, groups, roles, and policies to control access to AWS services. IAM also enables identity federation between a corporate directory and AWS services. For example, consider a situation where you are responsible for an organization's users. You could use IAM to set up a user account for each developer in your organization. Each user has an IAM user account that they must use to access AWS services. You could then create an IAM role for developers and associate the developer role with each developer's user account. The developer role can be configured with policies that control which services and operations the role can access. Developers then assume the IAM role to have the permissions they need to work in the environment. When updates are needed to the permissions developers require, the IAM policy associated with the IAM role is updated, and any developer assuming the role gets the required permissions. You will learn more about IAM in the next module. When you set up your development environment, you need to install your programming language of choice and an integrated development environment, IDE. AWS offers several language-specific IDEs for you to write, run, debug, and deploy applications. For more details about available AWS SDKs, IDEs, and toolkits, refer to Tools to Build on AWS at https://aws.amazon.com tools. For information about how to install your development environment, Follow the instructions from the technology vendors of the platform and the IDE. You can interact with AWS through the AWS Management Console, or you can interact with AWS programmatically. With programmatic access, services can be called through the AWS Command Line Interface, AWS CLI, the AWS Software Development Kit, SDK, for the supported language, or the Service Application Programming Interface, API. All AWS services are managed through a common, REST-like API. AWS provides an API for each of its services. You can interact with the APIs to access your AWS resources in 4 ways. Directly, you can call the APIs directly. AWS Management Console, an implementation of the API calls in a web console. It provides a rich graphical interface to a majority of the features that are offered by AWS. Note, occasionally, new features might not be available in the console when the feature initially launches. AWS Command Line Interface, AWS CLI, an open source tool that enables you to interact with AWS services by using commands in your command line interface. AWS Software Development Kits, AWS SDKs, packages that enable you to access AWS services and resources in a variety of popular programming languages. The AWS CLI and the SDKs provide flexibility. They enable you to create your own tools and customize existing AWS features. For example, you can create your own scripts or applications for launching EC2 instances that enforce using a specific set of Amazon Machine Images, AMIs, add a standard set of tags, and so on. You can use these access modes interchangeably. For example, you can create server EC2 instance through an SDK call. This instance can be queried for its configuration information by using an AWS CLI command, AWS ec2 describe instances. Finally, you can terminate the server instance by using the console. It might sometimes take a few seconds or a few minutes for changes made through the AWS CLI or the API to display in the console. For information about the AWS SDKs and AWS CLI, see tools to build on AWS at https://aws.amazon.com tools. When you use the command line, you can use various tools to call AWS services. AWS Command Line Interface, AWS CLI, is an open source tool that enables you to interact with AWS services by using commands in your command line interface. With minimal configuration, you can start using the command prompt in your favorite terminal program to access functionality that's equivalent to the AWS Management Console. For information on the AWS CLI, see AWS Command Line Interface at https://aws.amazon.com. AWS Tools for PowerShell offers the AWS Tools for Windows PowerShell and AWS Tools for PowerShell Core. They are PowerShell modules that are built on the functionality that's exposed by the SDK for .NET. The AWS PowerShell tools enable you to script operations on your AWS resources from the PowerShell command line. For more information, see AWS Tools for PowerShell User Guide at https://docs.aws.amazon.com. PowerShell Test User Guide depstools welcome.html. AWS Serverless Application Model, AWS SAM, Local is an AWS CLI tool for the local development and testing of serverless applications. For information about AWS SAM Local, see AWS SAM CLI GitHub repository at https://github.com/samcli. AWS Amplify enables you to create, configure, and implement scalable mobile applications that are powered by AWS. AWS Amplify provisions and manages your mobile backend. It also provides a simple framework so that you can integrate your backend with your frontends, including iOS, Android, Web, and React Native. AWS Amplify also automates the application release process of both your frontend and your backend, enabling you to deliver features faster. For more information, see AWS Amplify at https://aws.amazon.com. Amplify. For more information, see AWS Command Line Tools https://aws.amazon.com tools. How to get started with the AWS CLI https://aws.amazon.com. How to install the AWS CLI https://docs.aws.amazon.com. Test User Guide CLI chap install.html. Now, the educator might choose to demonstrate installing the AWS CLI. Calls made from the AWS CLI have a certain format. The command line always begins with AWS. This string is how you invoke the AWS CLI. The next component is a service command. This string is the top-level AWS service that you are calling. For example, Amazon EC2. For a list of currently supported services, see available services at https://docs.aws.amazon.com. Test reference available services. The operation subcommand is next. This string is the operation that you want to perform on that service. This example uses the run instances subcommand to request the creation of a new EC2 instance. Then, you specify any parameters. The parameters are any arguments that are needed to perform the operation. Argument names are preceded by two dashes, dash. For example, to create an EC2 instance, you must run the Amazon EC2 run instances operation and pass in several parameters, such as the Amazon machine image, AMI, ID. You can also specify options. The options are choices that you can specify when you run an operation. For example, you can use the query option to limit the response text so that it returns only the instance ID of your new instance. Some of the features of AWS Cloud Shell include: Cloud Shell inherits your credentials from the AWS Management Console. This means there are not key files to manage when using the AWS CLI. It runs on an Amazon Linux 2 instance that's fully managed. All the latest versions of the tools are installed without needing to update or patch the environment. It incurs no cost. Cloud Shell includes 1 GB of persistent storage per region. You only pay for the resources that you create and run on AWS. It's customizable, per region, for storing scripts, files, configuration preferences, and tools. Thank you for completing this module.
Hello and welcome. This demonstration covers the installation, configuration, and basic use of the AWS Command Line Interface, or AWS CLI. First, I'll show you how to install the AWS CLI on both Windows and Mac OS. Then, I'll configure the AWS CLI installation to authenticate with an AWS account. Next, I'll run some example commands to verify that the installation and configuration were successful. And finally, I'll show you how to use the profile feature to run commands against different accounts. Let's get started. First, let's review the purpose of the AWS CLI. The first time you ever accessed an AWS account, you probably logged in to the AWS Management Console using a browser. This is a popular way to access an account because it provides a graphical user interface. However, on occasion, you might want to interact programmatically with an AWS account by running commands, for example, from a terminal window on your laptop. You can do this with the AWS CLI. To use the AWS CLI, you first need to install it. Let's start by seeing how to do that on a Windows machine. Okay, so here I am on a Windows machine. I've already opened a browser and used a search engine to find the AWS Command Line Interface User Guide, which is hosted on the AWS documentation page. The user guide has step-by-step installation instructions. Notice that 2 versions of the AWS CLI are available. Version 1 is still supported, but the latest and recommended version is version 2. That's the one I'll install now. The AWS CLI can be installed on Docker, Linux, Mac OS, or Windows. I'll choose Windows. Notice the prerequisites. For example, you need admin rights on the machine where you're installing the AWS CLI. I'll choose the link to install the latest version. That prompts my browser to start downloading the installer package. Now that it's finished downloading, I'll open the installer and the welcome window displays. I'll choose Next. I'll read through and accept the license agreement, and then choose Next. I'll accept the default installation location and choose Next. And finally, I'll choose Install. After it finishes installing, I'll choose Finish. Next, I'll open a command prompt window. And finally, I'll run the command aws -- version to verify the installation. Notice that the response indicates that version 2 of the AWS CLI is installed. Excellent. The software is installed. Next, let's look quickly at how to accomplish these same steps on Mac OS. Okay, so here I am on a Mac OS machine. And just as I did when installing on Windows, I've browsed to the AWS Command Line Interface User Guide. I'll choose the link to install AWS CLI version 2. This time I'll choose macOS, and now I'll choose the link to install the latest version. And that prompts my browser to download the installer package. And now that it's finished downloading, I'll open the installer. The welcome window displays. Choose continue, and then choose continue again. At the license agreement window, choose continue again. Read through the license agreement and agree to it. I'll choose to install this for all users on this computer, and then choose continue again. I'll accept the default installation location, and finally I'll choose install. I'm prompted for my OS password to allow the installation, so I'll enter that. After it shows that the installation was successful, choose close. I'm prompted to move the installer to the trash, which I will do, and next I'll open a terminal window. And finally, just as I did on Windows, I'll run the command aws-version to verify the installation. And again, notice that the response indicates that version 2 of the AWS CLI is installed. Excellent, the tool is installed. At this point, I need to configure the software so that it can communicate with an AWS account. To accomplish that, I need to have some valid AWS user credentials. So here I am, logged into the AWS Management Console of the account that I want to configure the AWS CLI access to. I need to find my existing credentials or create new credentials, which I can then configure the AWS CLI software to use. Programmatic access is managed through the AWS Identity and Access Management, or IAM service. I'll search for that service in the search bar. Great, so now here I am in the IAM console. I'll select Users, and then choose Add Users. I'll give the user the name MyDemoUser. For access type, I'll choose Programmatic Access. That's all I need for the AWS CLI user. And choose Next Permissions. Then I'll choose to attach an existing policy directly. When you assign user permissions, AWS recommends always following the principle of least privilege. I want to use the AWS CLI to list the contents of a bucket in AWS Simple Storage Service, or Amazon S3. So I want to assign S3 read-only permissions to this user, but I won't grant any additional permissions. In the filter box, I'll filter for existing S3 service policies. And I'll choose the Amazon S3 read-only access policy. I'll choose Next Tags, and then Next Review, and finally I'll choose Create User. The user has now been created. Notice that because I granted this user programmatic access, an access key and secret access key were generated. I need to capture these credentials. This is the only time that this secret access key value will be available. The credentials can be downloaded as a CSV file, but for this demo, I'll just copy the credentials from this browser directly into the AWS CLI interface. I'll start by copying the access key ID. Now that I have a set of access credentials, I can configure the AWS CLI. I'll demonstrate this in a terminal on a Windows machine. However, if you are on macOS or another supported platform, the software behaves the same way. To begin, I'll run the AWS configure command. The first value it prompts me for is the AWS access key ID. So I'll paste in the value from the IAM console window and then press enter. Next, it asks for the AWS secret access key. So I'll return to the screen where that exists and copy it. And now I'll return to the terminal and paste that in. Next, the utility asks for the default AWS region to use when running commands. For region, I'll enter US East 1. The console has a complete list of region names and their values. Let's look at where to find that. So here I'll go back to the console, and in the top right area of the window, I'll choose the region menu. It shows the current region as global because I'm in the IAM console, and IAM is a global service. But notice the available options. The US East 1 region that I just set as the default is the Northern Virginia region. The utility now asks for the default output format that the AWS CLI will use to respond to commands. Available formats include JSON and YAML. The other available formats are YAML stream, text, or table. For this demonstration, I'll enter JSON and press enter to complete the configuration. I can now verify that I've configured the AWS CLI correctly. The user account should have read access to Amazon S3. So, for example, I should be able to retrieve a list of buckets in the account. First, I'll show you in the console that an S3 bucket with a file in it does exist. I'll search for S3 and select it to navigate to the Amazon S3 console. And here you see that this account has a bucket. If I choose the bucket name, you see that it contains a single object, a .png file. So if I run the correct AWS CLI command, I should be able to retrieve this information programmatically in the terminal window. You can find information about all of the commands in the AWS CLI command reference document. To find the command for Amazon S3, I'll scroll down to S3. Next, I'll scroll down to find the list of available commands. The ls command looks familiar to me. I'll choose that. The reference tells me that this command lists S3 buckets and their objects, and it gives examples for different scenarios. The first example, which shows listing all user-owned buckets, looks useful. I think I'm ready to try running a command. I'll try running the AWS S3 ls command. The command has a specific structure. It starts with the program name, which is AWS. Next, the command specifies the service to interact with. In this case, it's S3. And the next part of the command specifies the operation to run. This example uses the ls command, which lists buckets and objects in them. Okay, let's run it. Great, it found the bucket. So that's helpful, but what if I want to see the contents of the bucket? I could look back at the documentation, but I can also get help from inside the AWS CLI itself. I'll type AWS S3 ls help. Notice that the output contains the same information that was in the reference document. Excellent. Here I can see that for this ls operation, I could optionally specify an S3 URI. If I scroll down to example 2, it shows an example S3 URI. I just hold down the enter key to scroll through it, and then type Q to quit out of it. I'll use the up arrow on my keyboard to load the last command that I ran, and then add the S3 URI to it, which will be S3://bucket name. After pressing enter, the output shows a list of objects in the S3 bucket. It lists the .png file that we saw earlier in the console. I'd like to cover one more topic in this demonstration, profiles. So far, I've configured this AWS CLI installation to communicate with a single AWS account. However, by using profiles, you can configure it to communicate with multiple accounts. First, let's observe the profile I already created. The configuration information is usually stored in the home directory for the platform you're using, in the directory named .aws. On Windows, I can issue the command more%userprofile%\.aws/credentials to see the stored credentials for each profile. Notice that the credentials I entered earlier are stored in this file. To maintain security, it's important to protect this file from unauthorized access. Notice the first line of the file, which is default, meaning these settings pertain to the default profile. On macOS, you could view this file by running cat://.aws/credentials. I'm not going to run that on this Windows machine, but just know that if you are following along on a macOS or Linux machine, that's where the file is located. Okay, so regardless of OS, another file in the same directory stores the region and output preferences that I set. That file is named config. Notice here as well that the first line in the file is default. Let's try entering another set of credentials in a new profile. Okay, here I'm logged into a different AWS account, and I've already defined an IAM user and granted them access to the Amazon Elastic Compute Cloud or Amazon EC2 service. I've copied down the access credentials for this user already. Let's open the file and use those values to define a new profile in the AWS CLI installation. I'll copy the access key value, and now I'll return to the terminal and configure the new profile. I'll enter AWS configure --profile second account. I'm prompted for the access key ID, which I'll paste in now. And next, it asks for the AWS secret access key value. I'll copy that and paste it in. For the default AWS region, I'll again use US East 1. Finally, for the default output format, I'll set it to JSON. Let's view the contents of the credentials file again to see how it was updated. I'll run the command more%userprofile%\.aws/credentials to see the stored credentials. Notice that this file now contains credentials for both accounts. Now let's test. The second account should have access to Amazon EC2. I happen to know a command to test that service. I'll run the command AWS EC2 describe regions. I receive a permission denied response. Why? Oh, maybe because I did not specify to use the new profile. The account in the default profile doesn't have EC2 access, so that result makes sense. Let's try that again. AWS EC2 describe regions --profile second account. That's more like it. If I don't specify a profile in the command, it uses the default profile. And that concludes this demonstration of the AWS CLI. Thanks for watching.
Welcome to Section 4, Part 1, Fundamentals of Working with AWS SDKs. The AWS SDKs support many different languages. Whether you're using C++ to write back-end code, JavaScript to build your application front-end, or Python to work on big data, AWS offers an SDK to support your project. AWS also offers mobile SDKs to support languages such as Swift, which runs on iOS. For example, if you're using an Internet of Things or IoT device, such as a Raspberry Pi or Arduino, you can find AWS SDKs for supported languages on those platforms. When using the AWS SDKs, it's important to understand the request-response model that's used to call AWS service endpoints. Say that you have an application, and it uses an AWS SDK. In the request response model, your application initiates a request by using either the service client or resource APIs. We'll talk about those resources soon. When the application makes the request, the call is sent to the API that supports that service. After the service completes the work from the request, it returns a response object. Your application code consumes the response object, which contains information such as the results of a database query, output from a Lambda function, or the contents of an S3 bucket. Note the callout at the bottom of the diagram. The endpoint that your code calls is a URL. As long as your device has access to the internet, your application should be able to connect to the desired AWS service endpoint. In addition, the response codes that the service endpoint returns follow the standards for the HTTP response code series, such as 200, 400, and 500 series codes. Now we'll use code examples to look at what Service Client API and Resource API mean. The AWS SDKs have two levels of APIs. The first is the Service Client API, which represents the low-level client in the SDK. Using a low-level client gives you more control over the requests that you make to the service, which provides the ability to more closely control the behavior and performance of your calls to AWS services. In this code example, the list client function is written to access an S3 bucket called docExampleBucket. First, the client is instantiated by the client operation from the SDK for Python library. Next, the client calls the listObjectv2 operation on the bucket itself. This line sends a request object to the Amazon S3 service endpoint. If the bucket doesn't exist, it returns an error. The code then iterates over the bucket's contents. For each object that's found, the terminal prints its name and its last modified attribute. Now we'll look at the same functionality, but by using the Resource API. Resource APIs provide an object-oriented interface to AWS resources. Resource APIs provide a higher level abstraction than the low-level calls that service clients make. In the list resource function, first, an S3 resource object is instantiated by using the resource operation from the SDK for Python library. This resource object is then associated with the docExampleBucket S3 bucket. From there, the name of the S3 object and its last modified attribute are printed. Thanks for watching. We'll see you in the next video. Section 4, Part 2, Fundamentals of Working with AWS SDKs. In the previous samples, you saw code that interacts with Amazon S3. Bucket names are unique across AWS partitions, so it isn't necessary to specify an AWS region for an S3 bucket. However, some services have resources that are associated with a specific region. In these cases, you must specify a region. The slide shows a code example that specifies a region. The code is going to access DynamoDB, so it specifies where the table is located. The region name parameter indicates that the table is located in US East 1 region, which corresponds to the US East region in Northern Virginia. When the AWS SDKs determine what region to use, they follow what's called the default region provider chain. Here's an example. When you run code in Java, the SDK first looks for the region as it's specified in the code. This is what you see in the top example on the slide. Then, the SDK looks for the value of the AWS region environment variable. Next, the SDK looks for the value in the ~.aws/config file. This is shown in the bottom example on the slide. In the example, the region is set to US West 2, which corresponds to the US West region in Oregon. Next, if the code is running on an EC2 instance, the code uses the instance's metadata to determine what region the instance is currently running in. If the Java SDK cannot determine the region through these steps, client creation will fail. Other languages and their associated SDKs follow a similar chain to determine regions. Be sure to consult the SDK documentation to understand the specific region chain for the language you're using. Unfortunately, errors happen. When they do, error handling is key to elegantly handling the condition. The AWS service endpoints return error messages, which the AWS SDKs parse. In this example, a request was made for a JPEG image that doesn't exist. You can use the information in the error message to create a method to handle the condition. The HTTP response status codes can be useful when you need to decide how to handle various errors and conditions. With 400 series errors, the problem occurred on the client side. In this case, you, as the developer, need to handle the error. With 500 series errors, the problem occurred on the service side. When this happens, retry the operation. The AWS SDKs assist with 500 series errors by using an exponential back-off algorithm to retry the operations. Usually, retrying the operation results in success, and the program can continue. Each language supported by an AWS SDK has classes or functions to help you handle exceptions. Java, .NET, and Xamarin have the Amazon Service Exception and Amazon Client Exception classes. Python code can use the botocore.exceptions.client error class to handle exceptions. The SDK for JavaScript includes an asynchronous callback that contains error data. Regardless of where the error happens, whether it's in the client or as the result of a back-end exception, it's the developer's responsibility to handle the problem. An end user shouldn't know that an error occurred. Thanks for watching. We'll see you again in the next video.
Section 5, Introduction to Amazon Q Developer. To alleviate some of the challenges with writing code, AWS introduced Amazon Q Developer. Amazon Q Developer is a coding assistant that those without extensive experience can use. It is trained on years of high-quality AWS examples and documentation. It can also be trained on your company's code and systems. Amazon Q Developer can chat about code, provide inline code completions, generate new code, and scan your code for security vulnerabilities. It can also make code upgrades and improvements, such as language updates, debugging, and optimizations. With Amazon Q Developer, you can describe the application you want to create in natural language, and Amazon Q Developer will generate and suggest code for the application. You can build applications without needing to write all code yourself. The no-code approach of Amazon Q Developer can be particular. Section 5, Introduction to Amazon Q Developer. To alleviate some of the challenges with writing code, AWS introduced Amazon Q Developer. Amazon Q Developer is a coding assistant that those without extensive experience can use. It is trained on years of high-quality AWS examples and documentation. It can also be trained on your company's code and systems. Amazon Q Developer can chat about code, provide inline code completions, generate new code, and scan your code for security vulnerabilities. It can also make code upgrades and improvements, such as language updates, debugging, and optimizations. With Amazon Q Developer, you can describe the application you want to create in natural language, and Amazon Q Developer will generate and suggest code for the application. You can build applications without needing to write all code yourself. The no-code approach of Amazon Q Developer can be particularly useful for creating simple web applications, automating business processes, or building prototypes and proofs of concept. For more information, see Getting Started in the AWS Amazon Q Developer User Guide on the Content Resources page of your online course. Amazon Q supports developers across the software development lifecycle, SDLC, phases in several ways. Plan. You can use Amazon Q in the AWS Management Console to ask questions, receive best practices and recommendations, optimize Amazon Elastic Cloud Compute, EC2, instances, and learn more about the well-architected framework. In the Integrated Development Environment, IDE, Amazon Q can help you understand your code base and get up to speed on projects. Create. Amazon Q helps improve development productivity through inline code recommendations directly in your IDE or command line interface, CLI, using natural language to generate new features. You can ask Amazon Q questions without leaving the IDE. The inline code recommendations are available for multiple coding languages. For more information, see supported languages for Amazon Q Developer in the IDE in the Amazon Q Developer User Guide. Test and secure. Amazon Q helps you confirm that your code is working and secure through unit test assistance. It helps you to find and fix security vulnerabilities earlier in the development cycle. Operate. Amazon Q can help troubleshoot errors, for example, in AWS Lambda, Amazon EC2, and Amazon Elastic Container Service, Amazon ECS. You can analyze your VPC reachability and get better debug and optimization tips. Maintain and modernize. Amazon Q Developer Agent for Code Transformation helps you maintain and modernize code by upgrading projects to more up-to-date language versions. For more information, see Accelerate Your Software Development Lifecycle with Amazon Q in the AWS DevOps blog. In your integrated development environment, IDE, Amazon Q Developer can help you develop code features or make code changes to projects. You explain the feature that you want to develop, and Amazon Q uses the context of your current project to generate an implementation plan and the accompanying code to implement the feature. Amazon Q can help you build AWS projects or your own applications. Amazon Q Developer analyzes the entire project and creates a plan for you to implement the requested task. It might take a few minutes depending on the size of the project. When the analysis is finished, the chat panel displays a step-by-step plan that details the changes to your code. Scroll through the steps to review them. Then, when you reach the end of the plan, you have the option to generate code. This is not the final step, and you will have an opportunity to review the changes before updating your codebase. Amazon Q Developer generates code and proposes changes to add new features to your application by modifying existing files or creating new ones. Your codebase is represented in a tree structure. Modified or newly added files are displayed at the end of their respective folder paths. In the diff view, removed code is highlighted in red, while added code is highlighted in green. After reviewing the transformation summary, you can examine the specific changes Amazon Q is proposing in a file-by-file diff view. When Amazon Q Developer creates a new file, such as greetingresource.java, that didn't exist in your original codebase, it's handled differently in the diff view. The diff view compares the new file to an empty file, displaying all the new code as additions. Scroll to the end of the chat contents and you have the option to choose Insert Code. You can also regenerate code if you do not like the current suggestions. After the code update is complete, you can close the session. Finally, you can run a validation to verify that the new changes did not negatively affect the build. At the end of a clean install process, the terminal displays build success. The first tab displays the file tree and the second tab displays the code showing build success. Your code is ready for you to commit and deploy to your environment for testing.